Just kidding, just kidding. There's actually one more question. Oh my gosh, I didn't realize that when I made the last video. How embarrassing for you. I mean me, for us, all of us. Anyway, unknown metallic sulfate, XSO4, can be identified using a single displacement reaction. It tells you the mass of lithium, tells us the mass of X at completion. Additionally, the mass of lithium sulfate is determined after evaporation. So we know a lot of pieces of information. We should be able to identify X, maybe doing the law of constant composition or something like that. We might be using, I don't know, the law of conservation of mass. Let's try this. Let's see. We have, let's just make a little data table here. Lithium, we have sulfate, and we have element X. What do we know about the lithium? We start off with 17.4 grams of it, okay? What do I know about the sulfate? Ooh, I don't know anything directly, but I do know lithium sulfate. I know lithium sulfate is 137.8. And if lithium sulfate has lithium in it, I could subtract that out, and I would know the sulfate. So let's try that. 137.8 minus 17.4. Okay. 120.4 grams of sulfate. I have 120.4 grams of sulfate. And then element X is 30.5. 30.5 is the mass of X. I always like to just check and make sure my math is right. Both sides should total the same thing. So lithium sulfate is 137.8 plus the mass of X, 30.5, is 168.3. So that's the mass of the products. The mass of the products is 168.3. And then the mass of the lithium and the sulfate, X of sulfate. So let's just check that. X sulfate and lithium should add up. 120.4 plus 17.4 plus 30.5, 168.3. Good. All right. So the reactant's mass and the product's mass are the same. So we don't have anything that just disappeared, because that creates a whole conundrum that would have to be worked out that we don't really deal with in AP. But so how are we going to figure out X? We're going to use the law of constant composition again, most likely. We know the actual masses of some of these elements. We could use the periodic table to figure out the theoretical masses. In fact, let's do that. We have a compound right here. X sulfate is probably the easiest one to work with. I have sulfate's mass. I have X's mass. So I'm just going to set that as a ratio. I'm going to say there's 30.5 grams of X for 120.4 grams of sulfate in that X sulfate compound. And then I could say, well, sulfate, where could I find the mass of sulfate? The theoretical versus this is the actual. Theoretical mass would be found on the periodic table. So I got, a sulfur molar mass plus 4 oxygens. So the theoretical, or the molar mass of sulfate, is this. And then the only molar mass we don't know is X. So we should solve for the molar mass of X, and then we hopefully can use a periodic table to solve what that missing element is. If I could type into my calculator correctly, I'll tell you what I got. Okay, so I got the question mark is equal to 24.3 grams. So whatever mystery element X is, should have a molar mass darn close to 24.3. It's 24.3. Magnesium. It's the only one that's that close. It's actually 24.30 on the periodic table. We only have 3 sig figs because of some of our limiting data. So we look at the first 3. That's pretty darn close. So again, the law of constant composition is a great skill. That's the end.